Hello and welcome to yet another video of Cornerstones of Math. Today I am going to solve the following problem. Fx is a function defined on the set of real numbers, satisfying fx is positive for all real numbers x, and the integral of fx from 0 to a hyperbolic sine y is equal to inverse tangent of y for all real numbers y. Okay, that is an interesting relation. For the first problem, we need to find the integral of fx from 0 to infinity, and from b, we have to find the real number k, satisfying that integral of fx from 0 to k gives pi over 4. And in the last problem, we have to find this function fx. Alright, let's do this. The first problem is really easy. Since the hyperbolic sine function keeps increasing all the way to infinity, all we have to do is to simply take the limit where y goes to infinity. Then the left-hand side becomes the improper integral of fx from 0 to infinity. So this equals the limit of inverse tangent y as y goes to infinity. And using the graph of tangent function, we know what value does inverse tangent y approaches as y goes to infinity. It approaches to this vertical asymptote, which is x equals pi over 2. Therefore, the value of this limit is pi over 2, which is our answer. The second problem is also easy if we properly use the given integral condition. The first thing to notice is that this pi over 4 is equal to inverse tangent of 1. Therefore, if we substitute y equals 1 in the given integral condition, we have the integral of fx from 0 to hyperbolic sine 1 is equal to pi over 4. It is given in the problem that fx is a positive valued function. Therefore, if we consider a definite integral of fx from 0 to some positive number, we can easily deduce that the value of the definite integral increases as the value on the upper bound increases, since this area will increase. This means that there exists only one value of k satisfying the given integral equation. Therefore, we can confidently say that k is equal to hyperbolic sine 1, which is also equal to 1/2 times e minus 1 over e. And finally, finding the function fx. First, let us introduce the antiderivative, the indefinite integral of fx. Let one of the antiderivatives of fx be capital F of x. Then the left-hand side of this integral relation is capital F of hyperbolic sine y minus capital F of 0 by the fundamental theorem of calculus, and this equals inverse tangent of y. Differentiating with respect to y, we have small f of hyperbolic sine y, and by the chain rule, the derivative of hyperbolic sine y, which is hyperbolic cosine y, and on the right hand side, the derivative of inverse tangent function is 1 over 1 plus y squared. You can either use the inverse function theorem or integrate this function 1 over 1 plus y squared using trigonometric substitution to verify this. So we have f of hyperbolic sine y equals 1 over 1 plus y squared times hyperbolic cosine y. So in order to obtain fx, we let hyperbolic sine y as x. Then y is equal to inverse hyperbolic sine of x. Or you can use the fact that inverse hyperbolic sine function can be expressed in alternative form, which is ln x plus square root of 1 plus x squared. If you want to verify this, all you have to do is to simply use x is equal to hyperbolic sine y, hence it is equal to e to the power of y minus e to the power of minus y divided by 2, and solve for y. Moreover, as for this hyperbolic cosine y, we use the famous hyperbolic relation hyperbolic cosine squared y minus hyperbolic sine squared y equals 1. And we also use the fact that hyperbolic cosine function is always positive, which gives hyperbolic cosine y equals positive square root of 1 plus hyperbolic sine squared y. Hence it is equal to square root of 1 plus x squared. Therefore, fx is equal to 1 over 1 plus inverse hyperbolic sine x squared multiplied by square root of 1 plus x squared. Or using this for inverse hyperbolic sine instead, we can also write it as 1 over 1 plus ln x plus square root of 1 plus x squared squared times square root of 1 plus x squared. And that's all for today's video. Thank you for watching. Please don't forget to hit the like and subscribe buttons if you enjoyed this video, and I will see you in another video.